Welcome to this session of Modular Arithmetic and Congruences. First, let's start with concept of divisibility. Given two positive integers a and b, we use the notation a bar b to indicate that a divides b, that is, b is a multiple of a. For example, the positive divisors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. We can also express 13 divides 182, minus 5 divides 30, 17 divides 289, minus 3 divides 33, 17 divides 0. Floor function. The floor function, also called the greatest integer function or integer value, gives the largest integer less than or equal to x. For example, floor function of plus 2.5 is equal to 2, that is minimum of 2 and 3. Similarly, floor function of minus 2.5 is minus 3, that is minimum of minus 2 and minus 3. Similarly, ceiling function of plus 2.1 is 3, that is maximum of 2 and 3. Similarly, ceiling function of minus 2.1 is minus 2, that is maximum of minus 2 and minus 3. A division algorithm. Given any positive integer n and any non-negative integer a, if we divide a by n, we get an integer quotient q and an integer remainder r that obey the following relationship. That is, a equal to qn plus r, where r is greater than or equal to 0 and less than n, and q is a floor function of a divided by n. Now let us discuss about greatest common divisor. Greatest common divisors of positive integers a and b, denoted by GCD of a comma b, is the largest integer that divides both a and b. For example, GCD of 24 and 64 is equal to 8. Similarly, GCD of 63 and 72 is equal to 9. Now let us discuss about what is relatively prime or co-primes. If GCD of a comma b is equal to 1, then we say that a and b are relatively prime or co-primes. For example, GCD of 8 comma 9 is equal to 1. Therefore, we can say that 8 and 9 are relatively primes or co-primes. Now let us discuss about what is integers. So to represent the set of integers, we use the notation z. So integers can be from minus infinity to plus infinity. For example, minus 3, minus 2, minus 1, 0, 1, plus 1, plus 2, plus 3, up to plus infinity. They are all set of integers. To represent set of non-negative integers less than n, we use the notation z suffixed by n. And to represent set of non-negative integers less than a prime number p, we use the notation zp. And q is used to represent set of rational numbers, and r is used to represent set of real numbers. Modulus. If a is an integer and n is a positive integer, we define a mod n to be the remainder when a is divided by n. The integer n is called the modulus. A is equal to qn plus r, where r is greater than or equal to 0 and less than n. And q is floor function of a divided by n. And it can also be expressed as a is equal to floor function of a divided by n into n plus a mod n. And now let us discuss about congruences. Two integers a and b are said to be congruent modulo n if a mod n is equal to b mod n. This is denoted by a congruence b mod n. There are some properties for congruences. A is congruent to B modulo n if n divides A minus B. And then symmetric property. A is congruent to B mod n also implies that B is congruent to A modulo n. And then transitive property. A is congruent to B modulo n and B is congruent to C modulo n implies that A is congruent to C modulo n. For example, 29 is congruent to 4 mod 5, and it means that 5 divides 29 minus 4. That is 5 divides 25. For symmetric property, 29 is congruent to 4 mod 5. It implies that 4 is congruent to 29 modulo 5. Then example for transitive property, 29 is congruent to 4 modulo 5 and 4 is congruent to 24 modulo 5. This implies that 29 is congruent to 24 modulo 5. And there are some modular arithmetic operations. So A mod n plus B mod n, the whole mod n is equal to A plus B mod n. Then for subtraction, you have A mod n minus B mod n, the whole modulo n is equal to A minus B mod n. Then multiplicative property or operation, A mod n into B mod n, the whole mod n is equal to A into B mod n. Now let us discuss some examples. For addition, 12 mod 7 plus 13 mod 7, the whole mod 7 is equal to 12 plus 13 mod 7. So it means that 5 plus 6 mod 7 is equal to 25 mod 7. Then for subtraction, 12 mod 7 minus 13 mod 7, the whole modulo 7 is equal to 12 minus 13 mod 7. That is 5 minus 6 mod 7 is equal to minus 1 mod 7. Then multiplication operation, 12 mod 7 into 13 mod 7, the whole mod 7 is equal to 12 into 13 mod 7. That is 5 into 6 mod 7 is equal to 156 mod 7. So thing is with this modular arithmetic operations, so the right hand side is somewhat difficult to compute. So that can be reduced into left hand side. That is somewhat easier to calculate. So with this, I conclude this session. Thank you.